Hello everyone. In this session we shall move on to the next chapter, which is domestic wiring, and which is the second chapter in the third module. So in this chapter you are going to learn about meter board. You are going to understand the concept of meter board, distribution board, and different types of wiring system, different lamp connections, and then earthing. So what is the necessity of earthing, different types of earthing. Okay, so all these you are going to learn in this chapter. And so here the electric supply is given by the supplier up to the energy meter. So after energy meter, the electric supply is conveyed to different places of the building with the help of wiring system. Okay, so we know that the supply will be provided by the supplier. So later, and once it comes to the energy meter, okay, so where you find it at your places, so once it comes to once it reaches to the energy meter, then from the energy meter the supply should be conveyed or is conveyed to different places of the building with the help of wiring system. And so factors to be considered for selecting the wiring methods are, so what are the factors to be considered especially while selecting the wiring methods? So which are durability. Okay, it should have more durability, so of course the safety, and so cost effective, then appearance, so it should not look awkward, so appearance wise it should be good, and then so we should have the good maintenance, then accessibility. So these are some of the factors to be considered, while selecting the wiring methods. In service means the conductors which bring electrical energy from the nearest pole. So what is a service mean? So the conductors which bring electrical energy from the nearest pole carrying the secondary distribution system to the consumer's premises are known as service main. Okay, so as I have already told you in the first point, so here the conductor which bring the electrical energy from the nearest pole to the consumer premises is nothing but service mains. Next we have the concept called meter board and distribution board. So like here you can see, as I have already indicated, so the supply will be given by the supplier, and later it will be distributed to different places of the building. And before that, so you can just observe, so there are three different blocks, and initially the supply will be given by the supplier, and as we have already indicated, from the nearest pole, okay, energy meter should be provided from the nearest pole, so that is to the wooden box. Okay, initially to the wooden box, and this wooden box we call it as meter board. So you might have observed the meter board at your places, so which consists of fuse. Okay, so this is nothing but fuse, and here fuse or supply cutout, so we also call it as supply cutout. So here, so you can find single phase energy meter, so where the meter reader can read the energy. Okay, single phase energy meter, and this we call it as this block, and this block is made up of wooden box, so this we call it as meter board. So later from this, actually it has to be given, the supply should be given to the main switch. Okay, and this is nothing but the main switch, and this ICDP main switch we call it as iron clad double pole main switch. So later this will be converted, and from this point it should be given to the earthing. So this we call it as house earthing. So the proper earthing should be given, right? From this later, so we can provide the supply to the distribution board. So this block we call it as distribution board. So from here, so as you can see, so you have neutral point and then phase point. Okay, so from the neutral point, so that is, one is the ground point and another one is the phase point. So from this point, so we can have supply to different places in the building. So assuming this has one block and the other one as another block. So this is the overall figure of the meter board and distribution board. And so what are the different types of wiring system? So, and we also call it as conduit wiring. So here in conduit wiring there are two types of wiring system. So one we call it as surface conduit wiring, another one is concealed conduit wiring. In surface conduit wiring, conduits are, so it is again a conduits is nothing but it is again a wiring system. Conduit are fixed on the surface of the wall or ceiling by means of saddles. And remember, so you might have observed at your places, here the wiring system, the wiring is made with the, or it is made with the conduits, or it is fixed on the surface of the wall. Sometimes when it is fixed on the surface of the wall or the ceilings by means of the saddles, the conduits are spaced apart from the wall by wooden blocks. So you might have observed the wiring system, okay, is made with the wooden boxes. Of course it should be, it is fixed on the surface of the wall or the ceilings. That is nothing but surface conduit wiring. And next, the concealed conduit wiring, so where we find it normally, so the normal wiring system, that means conduit is buried under the wall or ceiling, okay, and of course it should be made before plastering, isn't it? So the channels are provided in the wall before plastering, so conduit is fixed in the channel by means of clamp, right? So before plastering it should be done, the wiring system should be done. This is nothing but concealed conduit wiring. And so next we have like different lamp connection, different ways of connecting the lamps. So here the first one is two-way control of lamp, right? The staircase lighting, so usually it is done with the two-way controlling of lamp. Look at the figure here. So we have, okay, so we have 4 different cases, right? So two-way controlling of lamp means, so in one side if I just make it on, okay, if I just switch on the, if I just make it on the other side, so how it operates, so that we are going to learn from this particular figure. And you can just look at the figure. So there is a lamp over here, there is a lamp and there is a supply. So there are 2 switches, right? So now we are controlling a single lamp with 2 switches, right? So we are controlling a single lamp with 2 switches. And look at the first part, the first circuit. So here, so in this connection, so in the first switch, so we have made it 1 and 2, and in the second connection, second circle, so we have made it this 1 dash and 2 dash. So look at the figure. In the first case, now the this 1 is connected to 1 dash, but 1 dash is not connected to this 2 dash, because this cannot be done. This switch, this connection cannot be done. 1 dash and 2 dash cannot be connected. In this case, what happens? The circuit becomes open circuit. Okay, the circuit becomes open circuit, so there will not be any supply, the current supply in the circuit. So what happens here? So remember, just according to the connection, so we have just considered the table over here. So position of switch A, so now let us call this as switch A and this as switch B. Okay, so what is the position of switch A? This is at 1, and similarly position of switch B is at 2 dash. See, look at this, position of switch A is at 1 and position of the switch B is at 2 dash. So what happens? Since there is no connection between this 1 dash and 2 dash, so what happens? The lamp condition will be off. The lamp will be off, the condition is off. And similarly, so look at the second figure here. So in this figure, okay, so instead of having 1 at the first figure, so here we have connected this switch A to 2, okay, and let it be a 2 dash. So what happens here? See, look at the figure carefully. The switch A condition, what is the switch position of switch A? That is at 2. So this is at 2 and switch B is at position 2 dash. So okay, so let it remain same 2 dash. So what happens? So when it is connected to 2 and it is connected to 2 dash, so this can be connected directly. And when it is connected, so there will be a supply in the circuit. The current flows in the circuit. It forms a closed circuit. When it forms a closed circuit, of course, the lamp, okay, so glows, or the condition will be on. Okay, condition is considered as on. And in the next case, in the third case, okay, so here the switch position of switch A is at 1. Okay, so it is at 1 and here it is at 1 dash. So it is at 1 dash. So what happens here? So there will be a connection. There will be a connection between this 1 and 1 dash. So remember, whenever we connect from switch A to switch B, it should be again straight connection. Remember, it should be a straight connection. it should be a straight connection. So here also you find a straight connection from one switch to another switch, and here also so you find straight connection, because this cannot be considered, right? So your diagonal connection cannot be considered between two switches, right? So look at the third condition. So here we have 1 and 1 dash. So what happens? So there will be a supply in the circuit, so it becomes again a closed circuit. So when it becomes a closed circuit, of course the condition will be on. See, and so when we look at the last circuit here, so in the last circuit, so here it is given to 2 and this is at remains 1 dash. See, look at this again, of course we have a straight connection between two switches, but now the switch A is at position 2. So since there is no connection between this line to this line, it becomes open circuit, because there will not be any supply in the circuit, and when it becomes open circuit, the condition will be off. The lamp doesn't glow. So this is about the two-way control of lamp. So next we have three-way control of lamp. So that means we can control a single lamp with 3 different switches. So how can we control? How can we control a single lamp with 3 different switches? Okay, so look at the figure carefully. So we have lamp here, and of course we have supply, and this is switch A, and this is like considering this as switch 1, and this is at switch 2, and now we call the another switch, we call it as intermediate switch. There is a switch between the switch 1 and switch 2. So the switch between switch 1 and switch 2 is nothing but intermediate switch. So based on the operation, so now we are going to analyze the table. So now in the first case, so position of switch 1 is at A, and position of switch 2 is at G, right? So now position of this 1 at A and this is at G, right? So and what should be the position of this intermediate switch? So again look at this. So we have position of intermediate switch is CD. So position of intermediate switch is CD. That means from C to D it is connected. So what happens here if we just directly connect from C to D? So of course the lamp will be on. So look at this. So we have the position of switch 1 at A and position of switch 2 at G, right? So position of switch 1 at A and position of switch 2 at G, and when CD is connected, then of course it becomes a closed circuit. So here the lamp will be on. And so next is, so we have A, then CD, but so look at this, just compare with the previous condition. So we have A and then CD, but instead of having G, so we have H over here. So what happens? So now we have a connection at A and then intermediate switch at CD. So next, instead of having connection at G, that is at switch 2, it is connected to H. So what happens? See, assuming that now this is connected till this point, now this is connected till this point, but instead of having connection to G, so we have a connection at H, that is at position, that is at in the second condition. So what happens here? So instead of connecting at G point, if it is connected here, of course this part will be open. So there will be a discontinuity in the circuit. So it becomes open circuit. Okay. So when it becomes open circuit, so of course what is the condition? The lamp condition is off. And in the next case, so we have B, okay, B, then E, F, G, right? So here, so how you can write the table is, you can write AA, so BB, and then similarly AA, BB, but here, so you can alternatively take GH, GH, and in this case, initially, so we can have CD and then EF. So that means initially we can have a straight connection, CD twice and then EF twice. So later we can have cross connection in the intermediate switch. So remember, so we cannot have cross connection between the switches, but we can have cross connection within the intermediate switch. I'll just repeat. So we can have cross connection cross connection in intermediate switch, but we cannot have cross connection between the switches. Between the switches means, so we can not have connection from this A to E. So remember, we cannot have cross connection between this A to E, right? And similarly B to C. So of course we cannot have cross connection between D to H and F to G, but we can have cross connection between this E to D and C to F. So based on this we are going to analyze the table. Now, so we have B, E, F, G, right? So we have, so it is at the switch 1 is at B, right? And then so now we have EF. So what happens here? It becomes a straight connection, isn't it? So till this point it becomes a straight connection, and then so now we have the second switch at position G. So now we have a straight connection, but this is at G point, right? So when this is at G point, of course there will be a discontinuity in the circuit, so it becomes off. That means lamp does not glow, isn't it? So, and instead of having G, so if we have the connection at H, what happens? See, that is what we have it in the fourth condition. So we have B, E, F and then H. So we have B, E, F and then H. So what happens? It becomes a closed circuit. When it becomes a closed circuit, so of course the lamp glows. So that is the fourth condition. Then I hope you have understood the first four conditions, and in the next case, see here, so these four we have taken it as a straight connection. So CD and then EF. So we have taken CD and then EF straight connection. Now let us look into same condition with switch 1 and 2, but let us look into different condition at intermediate switch. That means having the cross connection within the intermediate switch. So again, so A, right? So write down this A and then B. So A, now so we have CF and then G. So what happens here? So now it is connected to A, right? So and what is the intermediate switch? CF, right? So from A it is given to C, then so we have a connection between this C to F. This can be connected. Remember, there will be a, we can have a cross connection within the intermediate switch. So that means switch 1 is connected to A and intermediate switch is connected to C to F. So we can have a connection like this, and when it is connected, so here what is the condition? What is the switch condition of 2? See, look at this. Now we have at G. So what happens here? So now we have a connection from A, this C to F, right? But here, so if we have a connection at this point, so what happens? Of course there will be a discontinuity in the, there will not be any continuity in the circuit. So what happens? It becomes off. The condition becomes off. And similarly, so here the same condition has been taken. So A, CF. So A and then CF. So here instead of having G, so if we have the connection at H, position H, then it will get connected. So it becomes a closed circuit. So of course this will be on. So look at the condition of the lamp. So it will be on. And similarly, so we have, so in the previous case we have taken CF, right? And in the next case, so we are going to have the cross connection between this E to D. Okay, E to D. So here, and let it be at position A. So or position. Okay, now it is at position B. So now it is at position B, and of course when it is connected to E here, and so we have a cross connection between this E to D, right? So E to D, look at this, E to D, and so if we have a connection at G, so what happens? See, look at this. Now we have switch 1 position at B, then from this E to D. So of course this can be connected, straight connection, and here we can have a cross connection, and here when it is connected to G, of course it becomes C. Look at this, right? So we can have a closed circuit. So when we have a closed circuit, so the condition will be on. The lamp condition will be on. And in the next case, so we have B, similarly this D, right? But instead of having a G, so if we have a connection at H, right? So position H, so what happens? It becomes open circuit because there will not be any connection between this D to H. So what happens? It becomes open circuit. So the condition will be off. So these are all about the three-way control of is all about the three-way control of lamp. So we have discussed about two-way control of lamp, like how we can control a single lamp with two different switches and three different switches. And next, so you have circuit protective devices. So what are the circuit protective devices, right? You might have heard about the word called this fuse, right? So fuses, what is fuse? A fuse is a short piece of metal. It is a short piece of metal inserted in series with circuit which melts, okay, when it melts, so that is when excessive current flows through it and thus breaks the circuit. Remember, when the excessive current flows through it, automatically it breaks because it is a small metal, okay, or it is a short piece of metal, so automatically it breaks the circuit. So that is why it is called a circuit protective device. And a fuse is the simplest protective device used in an electrical circuit against overloading or faults. So when the overcurrent or the excessive current flows, of course when there is a fault in the connection or the overloading in the connection. So here the material used for the fuse element should possess the following properties. So what are the properties that it should pose? That is low melting point, high conductivity, free from oxidation, low ohmic loss. Now the common materials used for fuse elements are copper and tin, so lead alloy, silver and aluminum, etc. Okay, so these kind of the materials which we can have it for the fuse. And similarly, so miniature circuit breaker, so we also call it as MCBs. So this also you might have seen at your places, MCBs. So and what is a full form? Miniature circuit breaker. So circuit breaker or electrical switching devices which are used to protect, right? So why these kind of devices are used? So which are used to protect the electrical equipments and circuits under overload condition. So as I have already indicated in the fuse, so whenever there is a overloading or when there is a fault in the connection, short circuit condition. So when normal current is flowing through the circuit, the circuit breaker is in closed position, isn't it? So when the normal current is flowing, so this will be in closed position, and when over current flows, it opens, right? Of course it is similar to fuse. So automatically the short metal, it gets cut, right? So here flows, it opens, so that the fault current does not flow through the circuit, right? So it avoids flowing the false current in the circuit. So and next we have earthing, or we also call it as grounding. So what is earthing here? So earthing is the process of connecting metallic bodies of all the electrical apparatus and equipments to the huge mass of earth, right? So I hope you have observed how the earthing is done, isn't it? So here the process of connecting the metallic bodies of all the electrical apparatus and equipments to the huge mass of earth by a wiring or by a wire having a negligible resistance. So remember, that is by having a negligible resistance is called earthing. So this is the definition of earthing. And what is the necessity of earthing? Okay, so why should we consider earthing? So here earthing is necessary for the following reasons. So you can just look into the reasons here. So to protect human being from death due to shock in case of human body comes into contact with the frame of any electrical machinery appliances, or if any leakage current due to fault. So if there is any leakage in the connection, right, if there is any fault in the connection, so when human body comes into contact with such kind of connection, so what happens? So here, so we get a shock. So to avoid or to protect human being from death or due to shock, so we go for earthing. To maintain the line voltage constant, so we go for earthing. To protect the large buildings from the atmospheric lightning. Okay, so then to provide protection against excess current and electrical shock. Okay, therefore good earthing is that earthing which gives very low resistance to the flow of heavy current of the circuit. So these are the points which you can consider for necessity of earthing. So as you can see in this particular figure, so there are two figures provided here. So here earthing is not done in the first case, earthing is not done here. So what happens, and when there is a problem or when there is a fault in the circuit, so this will be grounded through the human being or human body. So in this case actually we get a shock. But if the proper earthing is done, over here, I mean in this case, so what happens? So even like if we touch, so it will be grounded directly to the grounded. So but here it is through the human being it will be grounded, but here when the proper grounding or earthing is done, so it will be grounded directly. And we have different types of earthing. So one we call it as pipe earthing and another one is plate earthing. So in pipe earthing, so you can see like here this is from the ground level. So these are the equipments that we keep it under the ground level, and of course at the bottom level, so you can find the alternate layers of salt and charcoal. As you can see here, alternate layer of salt and charcoal. So it should be done. So before we keep all these so equipments under the ground level and under the ground. So and this is the example of the pipe earthing. And so here the iron galvanized pipe is placed in pipe earthing, and why it is called as pipe earthing, because this is in the form this. So here, so we consider this as a pipe earthing, and similarly if we consider in the form of plate, right. So now it is kept in the form of plate. So of course you can find the layers of coal and so that is charcoal and salt. So this we call it as plate earthing. So the earlier figure is pipe earthing, and the next figure is plate earthing. And so next we have the topic called electric shock, and so precautions against electric shock and the preventions of shock. So in what is electric shock? A sudden agitation of the nervous system of the body due to the passage of electric current is called as electric shock. As you have already seen in the previous figure, that is in the necessity of earthing. So here a sudden agitation of the nervous system of the body, that is due to what? That is due to the passage of electric current is called as electric shock. And when a person comes in contact with a live wire supplying, isn't it? So when a person comes in contact with the live wire supplying electricity, he receives a shock. Fine. The maximum current that human body can withstand for short time, okay, for short time is not more than 25 milliseconds. So that means we cannot get this electric shock not more than 25 milliseconds, and that too it is only 30 amperes. The current is only 30 amperes. And what are the precautions against the shock? What are the precautions against the shock? And do not touch the victim with bare hands when he or she is still in contact with electricity. So when somebody is still with the contact with electricity, so we should not touch them, right? And so shut down the supply immediately. So when they get shocked, when somebody gets shocked, and so immediately we should shut down the supply immediately. And so of course we should not use any wet or the metal object to push the victim. So once the victim is free, so we have to check his pulse rate, right? So these are the precautions against the shock. And similarly, so we have preventions of shock. So what are the preventions? So already you are aware of these preventions. So we should not touch the switches or this distribution board, or what we call the switches, so with the wet hands and with any metal object, right? And then so whenever we operate the switches, like internal part of the switches or the wiring system, whenever we want to repair the wiring system, so the supply should be off, and so we should wear the shoes or the sandals. So these are some of the points of this electric shock and precautions against the shock, then preventions of shock. So these are the contents which you are going to study in domestic wiring. So it's all about the general concept of domestic wiring. Thank you.